Hello, my dear children. Welcome to the mathematics class. Today we are going to discuss limits and derivatives. Limits and derivatives. In this chapter, we are going to discuss the concepts of exercise 13.1. Concepts of exercise 13.1. In the previous class, we have discussed some points, some concepts of this exercise 13.1. I hope you understood, you have learnt well the concepts of 13.1, exercise 13.1. Now we continue that concepts. Today also we continue the concepts of exercise 13.1. Okay, my children, are you ready to listen the class? Right. See, algebra of limits. Algebra of limits. Let f and g be two functions such that both as extends to a limit f of x and as extends to a limit g of x exist. Means for this function and for this function limits exist. Okay, my children. And then see, first point, limit of two functions is sum of the limits of the functions. That is, we can write this sentence, we can write this property in the form of symbols like this. As extends to a limit of f of x plus g of x is equal to, as extends to a limit of f of x plus as extends to a limit of g of x. Understood this point, my children? So if there is a function, if it is a sum of two terms, then can find the limit of that two terms separately. We can find the limits of the two terms separately. Understood this point, my children? Right. Now come to the second point, second property. Limit of difference of two functions is difference of the limits of the functions. That is, as extends to a limit of f of x minus g of x is equal to, as extends to a limit of f of x minus as extends to a limit of g of x. If you want to find limit of difference of two functions, then we can find limits of the two functions separately and we can find the difference. Understood this point, my children? Right. Now come to the third point, third property. Limit of product of two functions is product of the limits of the functions. That is, as extends to a limit of f of x into g of x is equal to, as extends to a limit of f of x into as extends to a limit of g of x. Okay, my children, if you want to find the product of limit of product of two functions, now then we find the limit of the each function separately and we multiply them, then it is equal to this limit. Understood this point, my dear children? Right. Now come to the next property. Limit of quotient of two functions is quotient of the limits of the functions whenever the denominator is non-zero. Okay, my children, use these properties when you are finding the limits of the functions in the exercise. Okay, my children, please listen carefully. As extends to a limit of f of x by g of x is equal to, as extends to a limit of f of x by as extends to a limit of g of x. Okay, my children, here denominator, this is limit is not equal to 0. This denominator should not be equal to 0. Understood this point, my children? Right. Now come to the next point. If lambda is a constant, then as extends to a limit of lambda into f of x is equal to lambda into as extends to a limit of f of x. If there is a numerical coefficient then we can write it outside. It does not affect the limit of that function. Okay, that is why we are writing the numerical coefficient outside, then we find the limit of the remaining part of the function. Understood this point, my dear children? Right. Now come to the next point. As extends to a limit of modulus of f of x is equal to modulus of as extends to a limit to f of x. Okay, my dear children? Understood? Right. Next point. As extends to a limit of f of x whole to the power of g of x is equal to as extends to a limit of f of x whole to the power of as extends to a limit of g of x. For these both functions we have to find the limits and we write it in the exponential form. Okay, my children, understood? Right. Now come to the next property. If f of x is less than or equal to g of x and less than or equal to h of x, then and as extends to a limit of f of x is equal to as extends to a limit of h of x is equal to L. The limits of these end functions, this end and this end functions, limits are equal to some limit real number, some finite real number where L belongs to R, a finite real number. Then as extends to a limit of g of x is equal to L, the same finite real number. If three functions are like this and limits of these two n functions is equal to a finite real number, then the limit of the middle function is also the same finite real number. Understood this point, my dear children? Right. Now come to the next point, my dear children. As extends to a limit of f of x is equal to plus infinity or minus infinity. If the limit of this function is either plus infinity or minus infinity, then as extends to a limit 1 by f of x is equal to 0. Okay, my dear children, this is also one of the properties. We use these properties while you are finding the limits of the functions. Okay, my children, remember these algebra of limits. Okay, my children. Now come to the next point. Indeterminate forms. What is meant by indeterminate forms? When we are finding limits of functions, sometimes we get the limit of the form 0 by 0. Sometimes we get the answer in the form of 0 by 0, which is referred to as undetermined or indeterminate form or illusory form. This is called indeterminate form, undetermined form. Okay, my children. There are 6 other indeterminate forms. We get some other 6 other indeterminate forms are there. They are namely infinity by infinity, 0 by 0 into infinity, infinity minus infinity, 0 power 0, infinity power 0 and 1 power 0. All these are said to be indeterminate form. Altogether 7 indeterminate forms are there. 0 by 0, infinity by infinity, 0 into infinity, infinity minus infinity, 0 power 0, infinity power 0 and 1 power 0. All these are 7 forms are said to be indeterminate forms. Okay, my children, remember this point. Now come to the next point. To facilitate the job of evaluation of limits, we categorize problems on limits into following categories. The first one is algebraic limits and the second one is non-algebraic limits. Okay, my children, to evaluate the limits of the functions, we categorize the limits into 2 categories. They are algebraic limits and non-algebraic limits. Okay, my children, right. If a problem on limits does not involve trigonometric, inverse trigonometric, exponential and logarithmic functions, then it is a problem on algebraic limits. Otherwise, it is a problem on non-algebraic limits. Understood this point, my children? Right. Let us take some example to understand this point. Which limits are said to be, which problems are said to be problems on algebraic limits, and which problems are said to be the problems on non-algebraic limits. See these examples. As x tends to 1, limit of x cube minus 1 by x minus 1. Second example, as x tends to 0, limit of square root of 1 plus x minus square root of 1 minus x by x. Third example, as x tends to infinity, limit of x squared plus x plus 1 by 2x squared plus 5, etc. are problems on algebraic limits. If you observe these functions, in these functions there is no trigonometric function, there is no inverse trigonometric function, there is no exponential function and logarithmic functions. So these are said to be the problems on algebraic limits. Understood this point, my children? Right. Now come to some examples of non-algebraic limits. See, as x tends to a, limit of e power x minus 1 by x. See here exponential form, as well as here trigonometric function. So it is said to be non-algebraic, a problem on non-algebraic limits. As x tends to 0, limit of sine inverse of 2x by 5 sin x. If you observe this function, it involves inverse trigonometric function as well as here trigonometric function also. So this problem is said to be a problem on non-algebraic limits. Similarly, this third example, as x tends to pi by 4, limit of sin x minus cos x by 4x minus pi. If you observe the numerator, trigonometric functions are there. So this is also some example, one example of non-algebraic limits. Now come to the next example. As x tends to 0, limit of 2 power x minus 3 power x by x. If you observe the numerator, 2 power x is exponential function. 3 power x is also said to be exponential function. So exponential functions are there. So this is called non-algebraic limit. Okay, my children, understood this point? Right. Now come to the next point. Evaluation of algebraic limits. How to evaluate the algebraic limits? In order to evaluate algebraic limits, we have the following methods. Okay, my children. Well, when we are finding algebraic limits, we follow these methods. See here, first and foremost method is direct substitution method, and second method is factorization method, and the third method is rationalization method. Fourth one, by using some standard limits. By fifth method of evaluation of algebraic limits at infinity. We use any one of these 5 methods to find algebraic limits. Okay, my children, we discuss these points one by one. See the next one, fifth point number 5, direct substitution method. We are discussing direct substitution method. In the direct substitution of the point to which the variable tends to, we obtain a fixed real number. We get a finite real number. Then the number obtained is the limit of the function. In fact, if the point to which the variable tends to is a point in the domain of the function. Okay, my children, understood? Right. Then the value of the function at that point is its limit. In this method, we can find the limit of the function easily. Let us see the examples. Okay, my children. Evaluate as x tends to 1, limit of 3x square plus 4x plus 5. We have to evaluate, we have to find the limit of this function as x tends to 1. Okay, my dear children, right. Come to the solution part. By using the substitution method, we obtain as x tends to 1 limit of 3x square plus 4x plus 5 is equal to. In this method, just we substitute the point at which the variable tends to. Here x is tending to, x is approaching to 1. So just we substitute x is equal to 1 in this function. Then we get 3 into x square is there, so 1 square plus 4x is there plus 4 into 1 plus 5. Understood this step, my children? Just we substituted x is equal to 1 in this function. Then we get this step. Understood this step, my children? Right. That is equal to, let us simplify the terms. 3 into 1, 3 plus 4 into 1, 4 plus 5. Understood this step, my children? Right. Let us simplify these numbers. That is equal to, what we get? 12. So, therefore, as x tends to 1, limit of 3x square plus 4x plus 5 is equal to 12. This is the first and foremost method, my dear children. Remember this method. Substitution method, easiest method. Okay, my dear children. Let us take another example. Evaluate as x tends to 2 limit of x square minus 4 by x plus 3. Okay, my dear children. Come to the solution. Using substitution method, we obtain as x tends to 2 limit of x square minus 4 by x plus 3 is equal to. In this method, what we said, we have to substitute the point at which the variable tends to. What is the point at which the variable tends to? 2. X is tending to 2. X is approaching to 2. So we have to substitute x is equal to 2 in this function. Understood this point, my dear children? Is it clear? So x square is there, so 2 whole square minus 4. Understood the numerator, my dear children? Right. Whole divided by x means 2 plus 3. Understood the denominator, my dear children? Understood this step? Right. Now we have to simplify. We have to calculate. That is equal to, what we get here? 2 square 4 minus we write 4 as it is. Understood numerator, my dear children? Right. Divided by, what will you get in the denominator? 2 plus 3, 5. Understood this step, my dear children? Right. That is equal to, what will you get in the numerator? 4 minus 4, 0 by denominator we wrote as it is. Okay, my children, understood? Right. 0 by 5, any number 5, any number by a non-zero number, any number by a non-zero number, we get a 0 only. Understood this step, my children? Right. Therefore, as x tends to 2, limit of x square minus 4 by x plus 3 is equal to, what we got here? 0. Is it clear, my dear children? This is substitution method. Very easiest method and first and foremost method. Okay, my dear children, remember this point. Right. Now come to the next method. That is the factorization method. Consider the limit as x tends to a limit of f of x by g of x. Okay, my dear children, we are evaluating the limit of this function. If by substituting x is equal to a, f of x by g of x reduces to the form 0 by 0. If we substitute x is equal to a in the numerator as well as in the denominator, then we get numerator value is 0 and the denominator value is also 0. Then x minus a is a factor of f of x and g of x both. Understood this point, my dear children? So we first factorize f of x and g of x and then cancel out the common factor to evaluate the limit. Okay, my children? If you use the substitution method, sometimes we get 0 by 0 form, which is called indeterminate form. In this case, we have to factorize the numerator as well as the denominator by using the previous knowledge. Then we find the limit of that function by cancelling out the common factor. Let us take an example to understand this point clear. Evaluate as x tends to 2 limit of x square minus 5x plus 6 by x square minus 4. Okay, my children, we have to find the limit of this function as x tends to 2. Come to the solution part. In the substitution method, if we use the substitution method, what will you get? as x tends to 2, limit of x square minus 5x plus 6 by x square minus 4 is equal to, if we substitute x is equal to 2, because here the variable is approaching to 2, so we substitute x is equal to 2 in the numerator, in the denominator as well. So 2 whole square minus 5 into 2 plus 6. Understood the numerator part, my children? Right. Whole divided by, in the denominator x square is there, so 2 whole square minus 4. That means we substituted x is equal to 2 in this entire function. Then we get to this step. Understood this step, my children? Right. Now we simplify the numerator as well as the denominator. What will you get here? 2 square 4 minus 5 2s are 10 plus 6. Understood numerator, my children? Right. Divided by 2 square 4 minus 4. Understood the denominator, my children? Right. Again we simplify the numerator. What will you get to? 4 plus 6 10. 10 minus 10. What will you get in the numerator? 0. Understood the numerator, my children? Right. By 4 minus 4, what will you get in denominator? 0. 0 by 0. We got here 0 by 0, which is called indeterminate form. We should not get indeterminate form when we are finding limit of a function. Then we go to the next method, that is factorization method. So as x tends to 2, limit of x square minus 5x plus 6 by x square minus 4 is equal to, as x tends to 2, limit of, here we factorized. This is a quadratic expression. You know how to factorize a quadratic expression. In the 8th class, 9th class and also in 10th class we have learned. So by using that knowledge, we factorize this quadratic expression. The factors are x minus 2 is one factor and x minus 3 is the another factor. Understood the numerator, my children? Right. Divided by x square minus 4. This is also a quadratic expression in x. A square minus b square. Here 2 square can be, 4 can be written as a 2 square. So by using a minus b into a plus b, by using that algebraic identity, we get in the denominator x minus 2 into x plus 2. We factorized denominator also. Understood this denominator, my children? Right. What is the common factor in the numerator as well as in the denominator? X minus 2. We strike out the common factor. Understood this step, my children? Right. That is equal to, as x tends to 2, limit of, what are the functions limit left here, x minus 3 in the numerator divided by x plus 2 in the denominator. Understood this step, my children? Right. Now in this stage we use again substitution method. So put x is equal to 2 because x is approaching to 2. So put x is equal to 2 in the numerator as well as in the denominator. Again we go to the substitution method. What will you get here in the numerator? 2 minus 3 by 2 plus 2. Understood this step, my children? Right. Now we simplify numerator as well as a denominator. Okay, my children, that is equal to 2 minus 3. What will you get? Minus 1 by 2 plus 2. What will you get in the denominator? 4. So minus 1 by 4 is the limit of this function as x tends to 2. Therefore, as x tends to 2, limit of x square minus 5x plus 6 by x square minus 4 is equal to minus 1 by 4. Understood this method, my dear children? Factorization method. Right. Now come to the next method, that is rationalization method. Okay, my dear children? This is particularly used when either the numerator or denominator or both involve expression consisting of square roots, and substituting the value of x, the rational expression takes the form 0 by 0, infinity by infinity, etc. Okay, my children, understood this point? If the numerator or denominator or both involves square root, okay, my children, in that case we use this method, rationalization method. If you substitute x is equal to that particular number in that expression, if it takes 0 by 0, infinity by infinity, in this case we use this rationalization method. For example, to understand this point well, let us take an example. Evaluate as x tends to 0, limit square root of 2 plus x minus root 2 by x. Okay, my children. Now we are finding the limit of this function as x tends to 0. Okay, my children, understood? Right. Come to the solution. When we substitute x is equal to 0, if we use the substitution method, you know already explained, we discussed the substitution method means we have to substitute x is equal to this point, this value in the given expression. The expression takes the form 0 by 0. If you substitute x is equal to 0 in this expression, we get the numerator value 0 and denominator value also 0. You substitute that part and do that part in rough work, then you get 0 by 0 only. Then we rationalize the numerator. We get, see here, as x tends to 0, limit root of 2 plus x minus root 2 by x is equal to, as x tends to 0, limit of root 2 plus x minus root 2 by x into, what is the rationalizing factor? In the 9th class, we have studied rationalizing factor. So, root a minus root b. Then its rationalizing factor is root a plus root b. So, we multiply the numerator and denominator by the rationalizing factor of this number. Okay, my children. What is the rationalizing factor of this number? Root 2 plus x plus root 2 is a rationalizing factor of this number. So we multiply the numerator and denominator by this number. Understood this step, my children? Right. That is equal to, as x tends to 0, limit, we simplify numerator. If you observe the numerator, it is in the form of a minus b into a plus b, where a is equal to root 2 plus x and b is equal to root 2. So we use that algebraic identity in the numerator to simplify. So it is in the form of a minus b into a plus b, a square minus b square. Understood the numerator, my dear children? Right. Divided by, we multiply the denominator, x into root of 2 plus x plus root 2. Okay, my children, understood this denominator, my children? Right. That is equal to, as x tends to 0, limit of, now root 2 square root gets cancelled. What will get here? 2 plus x. So I wrote here 2 plus x. Understood this part, my children? Right. Minus. Here also root 2 square root 2 and the square gets cancelled. We get to only 2. Understood this part, my children? Understood the numerator, my children? Right. Whole divided by, we wrote a denominator as it is. Okay, my children. If you observe the numerator, here 2 minus 2 gets cancelled. Okay, my children. Understood? Right. So here observe this function, my children. That is equal to, as x tends to 0, what is the numerator we got here? X only. Only x left there. By, in the denominator we write x into square root of 2 plus x plus root 2. Okay, my children, continuation to this step. Okay, my children, understood this step? Right. Now here, if you observe, x gets cancelled, common factor. What will you get? X tends to 0, limit 1 by square root of 2 plus x plus root 2. In this step, in this stage, again, we go back to substitution method. Okay, my children? Means we have to substitute x is equal to 0 in this expression. Then we get square root of 2 plus 0 plus root 2 by using this substitution method. We get this step. Understood this step, my dear children? Right. That is equal to 1 by square root of, what will get here? Root 2 plus root 2. Understood this step, my dear children? Right. That is equal to 1 by root 2 plus root 2. What will get? 2 root 2. Therefore, as x tends to 0, limit, what is the function? As x tends to 0, limit 2 plus x minus root 2 by x is equal to 1 by 2 root 2. Understood, my dear children? Understood this rationalization method? Right. Now come to this method by using some standard limits. Okay, my dear children, we use some standard limits to evaluate limit of some functions. Okay, my dear children, right. Following are some standard limits. These 9 are said to be some standard limits. See, first one, as x tends to a, limit of x power n minus a power n by x minus a is equal to n into a power n minus 1. Okay, my dear children, right. Second one, as x tends to 0, limit of sin x by x is equal to 1. Third one, as x tends to 0, limit of tan x by x is equal to 1. Fourth one, as x tends to a, limit of sin of x minus a by x minus a is equal to 1. Next, as x tends to a, limit of tan of x minus a by x minus a is equal to 1. Sixth one, as x tends to 0, limit of log of 1 plus x by x is equal to 1. Okay, my children? Right. Seventh standard limit. As x tends to 0, limit of a power x minus 1 by x is equal to log a base e, where a is not equal to 0 and a greater than 1. Next, eighth standard limit. As x tends to 0, limit of e power x minus 1 by x is equal to 1. Okay, my children? Right. Now, we use this last one in evaluating the limits of trigonometric functions. Okay, my children, as x tends to a, limit of f of x is equal to, as x tends to 0, we replace a by 0. As x tends to 0, limit of f of a plus x, we replace x by a plus x or a minus x. We can use this one or this one. Then we proceed to evaluate the limit of the function. Okay, my children, understood these methods? Right. Come to some more standard limits, my children. 10th one, as x tends to a, limit of x power m minus a power m by x power n minus a power n is equal to m by n a power m minus n. Okay, my children? Right. 11th one, as x tends to 0, limit of sin kx by x is equal to k, where k belongs to real numbers. K is any real number. Okay, my children? Right. 12th one, as x tends to 0, limit of sin power n kx by x power n is equal to k power n, where k belongs to r. These are all can be used as formulae in evaluating the limits of the functions. Okay, my children? Right. Come to the 13th one. As x tends to 0, limit of tan kx by x is equal to k, where k belongs to r. 14th one, as x tends to 0, limit of tan power n kx by x power n is equal to k power n, where k belongs to real numbers. 15th one, as x tends to 0, limit of e power kx minus 1 by x is equal to k, comma, k belongs to r. Next, 16th one, as x tends to 0, limit a power kx minus 1 by x is equal to k, where k belongs to r. 17th one, as x tends to 0, limit of a power kx minus 1 by k is equal to k. I repeated this part. Same. Now come to this one. As x tends to 0, limit of a power x minus 1 by b power x minus 1 is equal to log a base b. Okay, my children, you have to memorize all these standard limits to evaluate the limit of the functions. Okay, my children? Right.